Hi, I'm Jay from Winterborn Bicycle Institute, and today we're going to be covering everything you need to know about bicycle chains. So the two basic chain sizes that we're going to be covering today are 1/8 inch by 1/2 inch and 3/32 by 1/2 inch. 1/8 inch chains are typically used on single speed bikes, BMXs, single speeds, internally geared shifting hubs, that sort of a thing. And 3/32 size is more for larger gear ratios, 7, 8, 9, 10 speed bikes. Okay, so here we have a couple of tools that we're going to use to show you the difference between the 3/32 and 1/8 inch chains. This is the Park CT3. The CT3 is intended for the 3/32 chain, and this is the CT7. This is intended for the 1/8 inch chains. I'm going to show you how to properly use this. The trick to using this tool and not breaking it would be to make sure that you insert the chain into the lower carrier. The upper carrier is not used. It's used for fixing a stiff link, but what we're going to be doing right now is we're going to be taking this chain apart just to show you all the moving components in the chain. So here's how we do this. So take the, here's the chain, and then here's the roller. The pin is what we want to drive out of the chain, or the rivet. The rivet is what's holding the chain together. It's holding the outer plates to the inner plates and the roller in the middle. So if we go ahead and we insert the roller so that it's sitting right in this carrier, and you want to make sure it's sitting nice and flush. And then I'm going to bring the screw portion of the tool down, so the business end of the tool is going to touch down on the rivet or the pin, and I'm going to drive this rivet out. I'm going to drive it all the way out. In modern chains, you drive the rivet all the way out, okay? And then you'd be replacing the pin that you drove out when you go to put it together. So I'm going to go ahead and I'm going to make sure that that pin is lined up with the pushing portion of the tool, and I'm going to apply some pressure to it, and I'm going to drive this so you can start to see the pin coming out of the rivet right there. I'm going to continue pushing this out until it comes out all the way. Okay, and then back the tool off. Got to pull it out like that. And then here comes some components of the chain. So I'm just going to line these up, and I'm going to take one more link apart. There's my pin that came out. Take another link apart, doing the same thing, lining the pushing portion of the pin up to, or the pushing portion of the tool up to the pin or the rivet in the chain. And I'm just going to drive it all the way out. Backing the tool off. And I'm going to push one more just so that we can see a full link. So here we have our pile of parts, and of course if a chain is disassembled to this point, you're not going to be able to put this back together again for a functioning chain. But what I'm doing right here is I just want to show you all the moving components in the chain. The chain by far has the most moving components of any other part on the bicycle. So here's our outer plates, here's our pin that we pushed out, here's our inner plates and the rollers. Now if you look at the inner plates, they do have an outside and an inside to them. The inside would be this portion right here. This allows the roller to sit on this little lip right here, and then this would be the part that would be facing the outer plates. So the proper orientation of this would be something like this. Okay. Here's our next inner plate here, and then here is our roller, right? So our roller is the part that is sandwiched in between the inner plates. And with this chain, the roller width would be indicative of a 3/32 chain because of its width. The width of this roller is 3/32 of an inch. And then here you see the pin that would drive through there. Here's our next set of outer plates. Here's our roller, our inner plates, and you can see that what do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 moving parts in one connecting link. Outer plates, inner plates, outer plates. That's one connecting link. So, multiply that over the length of the chain, and you're going to have how many moving parts there are over the length of the chain. Okay, so here's the CT7, and the reason we don't want to use the CT7 with a 3/32 chain is because of this distance. If we were to the ½ inch between the links is the same, as we noted, but the difference is that if I was to use this tool and push it down on these little carrier brackets here in the tool, if I apply this force, there's a good chance that I'm going to bend those. And certainly after repeated times of doing that, you will essentially break these little brackets here, the lower carrier of the tool. So if you look at how the 1/8 inch chain goes in, you'll see that when I start to apply pressure to the pin, that the plates are now supported fully against the bottom of the tool. So this will not break the tool. It won't break these brackets. Now the other thing with pushing a pin out with a 1/8 inch chain is you don't want to drive the pin all the way out. And that would be because we need to use the existing pin to put the chain back together again. So if I go ahead and drive this pin, well, with this one what I'm going to do is I'm just going to drive it all the way out to show you the difference between the components anyways. And then I'll demonstrate that in a second. There. And here's another one here. Okay, so here's our 1/8 inch chain inner plates. And you'll see that they have these little stamped ledges, again for the roller to sit on. But here's the primary difference between the 1/8 inch roller and the 3/32 roller. If we line this up on a ruler, obviously it's 1/8 of an inch wide. And we compare it to the 3/32, which is much narrower. So here's our 1/8 inch chain again, and I'm going to show you you want to drive this pin on the 1/8 inch, because we're going to be reusing the pin, just enough so that we can disassemble the chain without bending the links. And the idea is, that's not quite enough. The idea is that you want to reuse this pin again when you go to reconnect the chain. That might be enough this time. And you'll see that I've left that little bit sticking out, and that's going to help for our chain reassembly. So when we go to reassemble this chain, then basically you're going to be using that little pin just to line up the hole in the inner plates, and now we can back the tool off enough and then put the pushing portion down and drive the pin back in using the same pin, showing equal distance of the rivet on both sides of the outer plates, and then making sure that the link does move freely, that we don't end up with a stiff link. And that would be the reassembly process for an 1/8 inch chain. So here we're looking at a diagram of some outer plates of a bicycle chain. I have this up basically to show you the distance between each of the rivets. The rivets are the points that hold each link together, and they're spaced out exactly 1/2 inch apart, and that's for both an 1/8 inch chain and a 3/32 chain. So what happens over time as you ride your bike, just through regular use, is as the drivetrain goes around, the chain goes around the drivetrain and propelling the bike forward, these rivet holes will start to wear. So a lot of people have heard the term chain stretch before. Well, chains don't actually stretch. They don't stretch in the sense that material isn't fatiguing and stretching. What is happening though is that these holes will ovalize. And so they actually get to be slightly longer there, something like this. And it's really only a small amount that they're changing, but of course, over the length of the chain, it's a significant amount because there's, you know, anywhere between 110 to 116 links in a chain, depending on how long the frame is and how long the drivetrain is. So because of the length change becomes longer between the chain rivets, the rollers, which would be under here, you can't really see them, but they would be underneath the outer plates. As I've shown you when we took the chain apart, they start to ride up on the backs of the teeth of either the cog or the chain ring or the cassette. And that's what actually causes the wear to your drivetrain. So the idea is that you want to change out the chains frequently. You want to also keep an eye on your chains. You want to make sure that you're measuring them using a proper measuring tool like the CC3 every once in a while, every few rides, just to determine the wear that's happened in the chain. Also, you want to keep your drivetrain nice and clean, i.e. your chain nice and clean and lubed as well, and that's going to help elongate the life of the chain. And the longer you get out of the chain, the longer you're going to get out of the drivetrain. But the trick here is to make sure that you're on top of checking your chain length or your chain wear using a proper chain wear indicator before the chain actually causes damage to the drivetrain.